I was dreaming of days that are gone.
The Massachusetts Military Reservation, MMR, is a 22,000-acre military training facility located in the upper western portion of Cape Cod. Established in 1935 by the Commonwealth of Massachusetts and the United States War Department, the reservation is currently home to 5 military commands. The site has been used for military training and aircraft operation and maintenance activities for more than 90 years, beginning with the establishment of a National Guard training facility on the grounds in 1911. Prior to the 1990s, there was little understanding of the environmental risks posed by these activities, or how this could potentially affect the health of thousands of Cape Cod residents. However, growing public awareness and concern over public health and environmental issues led the government to study the impact of hazardous materials used during these activities on the local water supply. An analysis of past and present operations and waste disposal practices identified several potentially contaminated areas, resulting from chemical and fuel spills, firearms and explosives, training activities, and unlined landfills. To date, the Air Force Center for Engineering and the Environment has installed 105 extraction wells with more than 27 miles of pipeline and has constructed 9 treatment plants to treat extracted groundwater through granular activated carbon (GAC) media. The treated water is then returned to the aquifer through reinjection wells and infiltration trenches or discharged to local rivers. Let's look at ECC's role in this process. We are talking today with Kim Johnson, Project Manager of ECC's groundwater treatment operations at the Massachusetts Military Reservation on Cape Cod.
We currently have 3 task orders. Under 2 of the task orders, that's what includes the groundwater treatment facilities. We have 11 treatment facilities that we maintain, we operate and maintain in 5 different locations. There's 15 extraction wells between those 5 locations, and that is probably a total of flow rate of about 2,000 gallons per minute, which equates to 2 million gallons per day.
Granular activated carbon, which we call GAC, is actually thermally processed. It's a small porous particle. When the organic matter molecules, whether it be RDX, HMX, there's a million others, comes through the carbon, the activated part will adhere the contaminants to the carbon.
Okay.
And allowing the water to come through the vessels where we sample it, and we get a clean or a non-detect result.
My name is Phil Morrison. I've been at ECC since June of 2008. I'm the chief operator. We operate this plant plus 10 other smaller mobile units, and we basically pump them out of designated wells, influent wells.
The systems were built between 2005 and 2007, and startup was, for most of the systems, in June of 2007. Since 1999, ECC has been here on numerous contracts, starting with the ASTI contract.
I see.
That was a worldwide remediation contract.
So this plant that we're sitting in right here was built in between 2005 and 2007?
Yes, startup was June of 2007.
And this is the largest plant on the reservation?
This is the Frank Perkins treatment facility.
These are a separate train, okay? From this filter here, it goes up and it goes down into the far train. These are just copycats of each other.
Okay.
You've got 2 resin vessels.
That's these first 2 right here?
Exactly, yep.
What does the resin look like, Phil?
They're little tiny, it almost looks like beach sand.
Really?
Little tiny, grains. They're very slippery. I don't know what it's made of exactly.
And are these vessels full of them, or is it
probably 3/4 of the way?
Okay.
Yeah, half to 3/4 of the way.
So the water enters the top of the vessel.
Yep.
And then it's a gravity drop for the water through the resin?
Yes,
The media that is used to treat the water here is granulated,
Granular
correct?
activated carbon, we call it GAC. Yes, our contaminants are RDX, HMX, and perchlorate. Conventionally, GAC is used to treat organics. But the treatment train we use at most of the sites here is actually a technology of IX and then GAC. The IX is to treat the perchlorate, which is an inorganic, and the GAC is for the RDX and HMX, which are organic.
They could say that at this flow, over this amount of time, we will lose this. We will treat this much contamination.
I see.
Okay, so yeah, so that's why these vessels are 20,000 pound each.
It leaves sufficient time at that size to do its job.
Exactly.
Okay.
Yep. And same with the carbon vessels as well.
I see. The inorganics, are those heavy metals? Is that what is being treated?
Inorganic is perchlorate,
okay,
specifically here, but yes, metals and other constituents.
So after it goes through the resin,
Yep.
does it go to GAC as well?
Yes. Yep.
Okay.
The resin is set up parallel so that the flow goes through both of them at the same time.
Oh, okay.
All right.
And they're identical. It's the same thing going
yes.
on in both.
Yep. The carbon is set up in series so that it goes into the first, out of the first, into the second, out of the second, into the third, and then it goes out.
All the water goes through all three steps.
Right, not at the same time. See, the carbon normally breaks through before the resin will. So that if you do get breakthrough, it's letting you know that, okay, we can still run, that this has reached its saturation point,
okay,
but we can still run because we have the other two vessels.
Two more backups.
Yes.
I see.
Right. If these were to break through, we'd have to change them pretty quickly.
Right.
You know?
But if the first vessel on the GAC starts to reach saturation,
yep,
it's because that's the first place it's hitting, so of course it's going to take the brunt.
Exactly.
And then the next two get less and less bad stuff because there's less to be had.
Right. And until you can change it, what you would do is you'd make the second one the lead. So then now it's hitting that one.
Okay.
And you may even take this one offline until you change it.
Wow.
Then once it's changed, that becomes your guard vessel,
yep,
you'd say, you know? So you'd have lead, lag, and guard. Sometimes what this job is you never know. You can come in and everything could run fine, or
yep, you
could have issues, and it's never the same thing every day.
Yep.
I mean, granted, you have to go check, make sure the systems are up and running.
Yep.
But sometimes you have systems, like I said, with the lightning. We have electronic issues. All these systems are run through a computer.
Yep.
They have little modules. Modules go. You have lightning strikes that takes out, you know, and then there's just the maintenance. You know, you
yep,
try to say, you know, how can I keep these buildings and all these pumps and systems,
yep,
you know, going and operating at peak efficiency.
We have such a great team here. I've been here at MMR since 2000. I started with ECC in August of 2000, so I'm 11 years in. ECC is a great company to work for. People that I work with, we've been a team throughout the 11 years for a majority of it. So we're seamless. We all know what we have to come in here and do. We all know what our job is. We all get along really well. We all work together.
And I originally got into environmental just because I'm, you know, hoping to try. Yeah, maybe we can do something. You know?
We have a great relationship with the Corps. I've worked with a few different project managers in my time on this contract, and over the past 3 years, we've had exceptional ratings through them. So I think overall, I mean, we all work really well together. I mean, the work is the work. I mean, we come in and it's hard work and we do it, but overall I have to say it's the team.